Hi, hello everyone. Good evening. How are you all? How are you all? Hi, Ankit. Am I audible, right, Ankit? Properly? Let me know through the chat box. Actually, you're watching on YouTube. How are you all? It's clearly audible to everyone. Okay, guys, we'll start our today's session within 2 minutes. Let them join. I'm waiting for some other people also. If they are join means immediately we're going to start our today's session. Okay, we'll wait for further 2 to 3 minutes. Uh, Yes, guys, in a last class we discussed, we started the waves, correct now? Waves से start हो गया, wave equation लिख दिया हम, wave से displacement equation हो गया, and later on velocity, acceleration, right? Like that we completed completely oscillation, and also yesterday we started with the wave. Wave क्या होता है, right? Wave is a kind of disturbance I told, right? During the when the disturbance will be created at the time क्या होता है, वे एनर्जी विल बी प्रोपोगेट होता है इन अ मीडियम, राइट? when energy will be propagated through the medium, during that time I told you guys. Yes, hi Ansari, how are you? Energy will be only propagate throughout the session, throughout the medium, but one thing we need to confirm here, always the particle will be vibrate in their mean position, and the particle will not move in the medium. Only the energy will be flowing through the medium. क्या flow होता है, energy flow होता है, right? Energy will be flow when wave will be oscillate. The particle का काम क्या है, just it will be vibrate in their mean position, right? Yes, good bro. Which JNV you are? You are belonging to which JNV? No. Um, okay, cool. No problem. No problem. Okay, no, no worries. Okay, these are the things which we discussed in our yesterday class, right? And today in this class, we are going to discuss about, and majorly yesterday, few things what we discussed, we're going to definitely recall that one. And before that, today what we are going to discuss, that one I will explain first. Okay, equation of progressive wave, first concept. Second concept है intensity of wave. Third concept है superposition of wave. And if I will get time means I will explain the Doppler effect in a brief way, not in a calculated method. Because yeah, if I want to explain the Doppler effect for the purpose of JE and NEET means I need minimum 30 minutes for solving one problem and explaining the concept completely. Okay, that much of time we don't have. Okay, in a coming days after your examination, definitely I will take again wave and I will complete this concept in a brief way. Okay, चलो आज का क्लास स्टार्ट करते हैं. Yes, hi Prasanna, hi JNV Ballari team. Good. Okay, आज थोड़ा लेट से आ रहा है. What happened? Okay, before starting the session, let us take a quick recall. Wave क्या होता है? Actually, we discussed that wave is a kind of disturbance which is produced in a medium. Correct? Now, yesterday I told you that when we are standing in a bank of a river or anywhere, okay, हमारा जन्म सिद्ध हक है क्या करना? We need to throw a stone inside the water. When we throw a stone inside the water, water is a kind of medium here, right? When the stone will be drop inside the medium, it will be create something pattern over the surface of the water. That pattern we call the wave. Correct now? Pattern which will be produced here. Actually क्या हो रहा है इधर? एक wave will be moving like this, right? That is we call wave. Clear है ना? Wave means simply it's a disturbance produced in a medium. And then next thing what we discussed, wave ko we define or we segregated in two ways. First one is mechanical wave, second one non-mechanical wave. Correct ना? Mechanical wave क्या होता है? Mechanical waves are the waves which required medium. Why it is required medium? To propagate. Or else we can say if energy will be moving from one point to another point means the energy move करने के लिए एक medium का जरूरत पड़ता है. Okay, that energy will be flowing in terms of wave. Okay, the energy will be flowing in terms of wave, right? And this wave required one medium to propagate. That's why we call this one as a mechanical wave. If energy will be flowing or propagating point A to point B without medium, क्या इधर है? Without medium also it is propagate. Okay, when it will be propagate without medium, at that situation we call like this wave को non-mechanical wave कहते हैं. Clear है ना? And then mechanical wave को example we can take sound waves, right? मान लो inside the classroom I'm teaching. When I'm teaching, actually if I'm going to remove all the air inside the classroom, if I'm talking even loud also, you people can't able to hear it, right? Somebody is saying like that, sir, even if you are removing all the air inside the classroom, we can't able to live also the time. सुनने का बात बाहर है, right? We are not पहला जिंदा भी होना चाहना है ना, right? That's also right thing, right? Sound required a material medium. Second one, mechanical wave, non-mechanical wave. Non-mechanical wave ko we are taking it's an as light wave. Okay, light energy is coming from sun to here on the surface of the earth. The atmosphere is only limited for on the earth for a certain distance. For a certain distance. Yes, yes. JNV Ballari team. Actually today I'm talking very loudly with a headphone. I kept my headphone near my mouth. Okay, it's very intense sound I'm talking. Okay, still I will increase for you guys. Okay, no worries. थोड़ा वॉल्यूम भी इंक्रीज कर दो उधर. इंक्रीज ಮಾಡ್ಕೊಳ್ಳಿ ಅಲ್ಲೂ ಕೂಡ ವಾಲ್ಯೂಮ್ ಸ್ವಲ್ಪ. Right. Light waves and as well as heat waves. Heat waves. These are the examples for. Yes. Okay. Cool. Heat waves. Okay. these are the major one. Next thing is that we are going to divide the waves in terms of vibration. Based on the vibration, we divide the wave into two category. One is transverse wave, second one is longitudinal wave. Transverse wave क्या होता है? Transverse waves are the waves which are actually moving perpendicular to their vibration. देखो इधर इधर एक particle है. This particle will be vibrate up and down. When it is moving up and down, after then the neighboring atom or molecule will receive the energy, then it will start to move up and down, and further one up and down. Like this, the vibration of a particle will be takes place, and the energy will be carried in this direction, right? Energy carry होने के direction को perpendicularly the molecules will be vibrate, right? Like this wave we call ट्रांसवर्स वेव. ट्रांसवर्स वेव क्लियर है ना? इसको एग्जांपल लाइट वेव है ट्रांसवर्स वेव के लिए. क्लियर ना? लाइट वेव्स एक्चुअली विल कम लाइक दिस, sinusoidally varying waves. They are actually vibrating in perpendicular direction. That's why. Clear? Coming to the next one, longitudinal wave. Longitudinal wave means, मान लो this is a particle. The particle is vibrating along the direction of propagation like this. It will be move forward and give the energy to the neighboring molecule, and it will become to its original position, right? To and fro motion करता है along the direction of propagation of energy. Energy direction के लिए in the same direction the molecule will get vibrate. Like this wave we call longitudinal waves. These are things which we discussed yesterday. Next, characteristics of wave. In characteristics of wave, we talk about wavelength, frequency, time period, relation between frequency and time period, relation between frequency, velocity and wavelength also. Wavelength क्या होता है? Distance between crest to crest, RS distance between trough to trough. Okay, now this is what the wavelength. Frequency, how you are going to define? Frequency is nothing but f, or else we can talk this one as a nu is equal to 1 over time period. Time period क्या होता है? Time taken by the wave to complete one cycle or oscillation. One complete oscillation करने के लिए कितना टाइम लगता है उसको हम कहते हैं time period. We will call that one as a time period. Clear? Next one, relation between frequency and time period क्या होता है? Yes, already I told you here. Frequency will be inversely proportional to the time period. This also yesterday we discussed. And later on, relation between frequency, velocity, and wavelength. Here, actually, when wave is moving, मान लो this is a wave which is moving with some velocity v. At this condition, this wavelength will be lambda. To complete this lambda, it will take the time t, that is a time period. Based on these quantities, we derived one equation for it, right? What is that equation? Actually, v is equal to lambda by t. Correct now? Here 1 by t, we written v is equal to lambda into nu or nu lambda. This is also we discussed. Next, wave profile move. It's a unique direction move. Progressive wave characteristics. All the particles vibrate in the same amplitude. Yesterday we discussed, yes, all the particle will be vibrate. Mando, this is a particle which is vibrating. This much means after receiving the energy of the second molecule, this molecule also will move up to same height which is done by the first particle. Clear? And the third particle again, it is also moving in a same amplitude. Means all the particles in a homogeneous medium will move in a same amplitude. Amplitude सबका same होता है, right? And then neighboring particle vibrate with the different phases. Yes, different phases means a particle का phase कितना theta value, or else we can say omega t value. the same value will not be the for the second part. It will be different. Okay, different particle will vibrate with a different phase, but amplitude same होता है, height same जाता है, but angle different होता है. And then all the particle will be vibrate, of course, produced in a disturbance medium. Of course, medium होने से disturbance produce होता है, and transmits the energy. Of course, they are vibrating means there is a wave will be created. That wave will be carry the energy from another, right? These are other things which we discussed in the last class. If you have any doubt means please tell me in a chat box. Do tell me in a chat box. Today also we are going to learn something new. Is all the things are clear, right? Is all the things are clear? Sorry, clear? Guys, today I'm going to do one concept. This is very important. That is equation for progressive wave. This is very important topic. Every year, one question you can expect in a NEET and as well as JEE. Even. Okay. We'll start. Hope there is a no doubt. Okay. मान लो इधर. मान लो. This is a particle. Guys, listen. This is a particle. At time is equal to 0. क्या करता है? Energy receive करके vibrate होता है. Will move upside and again it is moving downside. When it is moving up and down, there is a wave will be created instantly. That wave which carries the energy in forward direction like this. Correct now? It will carries the energy like this. When wave which is moving means in this direction, it has a velocity v. Here v stands for wave velocity. V stands for, guys, लिख दो इसको. V stands for wave velocity. Clear है ना? Okay, मान लो the wave is moving at a for a distance x from the origin. From origin से x distance क्या हो गया? Wave move हो गया up to this point. In this point also there is a particle p. After receiving the energy क्या होता है? Particle will move upside. Particle will move upside after a time t. I don't know the time t, that one. Okay, this is the main things. Okay, now guys, do listen. How are you going to define the time period here? Or else velocity क्या होता है? देखो, v is equal to x by t होता है ना. डिस्टेंस कितना ट्रेवल किया आफ्टर टाइम t. वेलोसिटी विल बी क्या हो रहा है इधर? x by t हो रहा है. If you are going to, yes Prasanna, have any doubt? You have any doubt? Prasanna, you raised your hand. Hi Mandya, Jainmi, how are you all? Okay guys, bro, if you have any doubt means please drop your doubt in a chat box. Let's stay in a call after 4:10. We'll discuss. Okay, keep your note your doubt in a notebook. I will make a open-end session. At the time you can talk, no worries. Okay, here if you are going to change the equation for time means क्या होता है? Time will t is equal to x by v होता है. Correct है ना? Basic things. Next क्या है? देखो इधर. At t is equal to 0 at origin. Exactly किधर? At origin. Exactly at origin. Displacement हो रहा है ना? इसके लिए इक्वेशन बनता है y is equal to ये sin omega t. I'm going to call this equation number 1. I will call this equation number 1 for y at wo. Y at wo means origin में इसका value इतना ही था. Clear ना? And when it is moving to a point P, मान लो this is a point P. At this point, also, this particle will receive the energy and it will jumps to the same height. What will be the height it jumps? No, same height it is done by the first particle in the origin, right? First particle, if mando this much of height will be done by the particle, means same height will be, amplitude will be created by the particle after the time t is equal to x by v, right? For this particle, if you're going to write the value of y value, now the value of y at p will become a sin ओमेगा t है ना, इसको हम यहाँ डिस्प्लेसमेंट में लिखना पड़ता है, then it will be t minus x by v we will write. Guys, please note on this equation, instead of t we are writing here t minus x by v, because here the particle which is at this point है ना, this particle which is vibrating some amplitude, with some amplitude, this amplitude already created by the particle at origin. With respect to this one, we are writing in terms of t, that time we are writing that time as an t minus x by v. Call this equation number 2. Note down this 2 equation first. Note down. From this point onwards, few equation will come, guys. They are really good equation for understanding the wave. Clear enough? Okay, cool. Next क्या करना है? Next omega को inside multiply कर दो. When you're going to multiply inside the omega, then the displacement will be, wave equation will become y is equal to a sin omega t minus omega x by v हो रहा है. Correct ना? Omega x by v. Clear? Clear ना? And moreover, guys, देखो इधर ओमेगा बाई वी है ना, ओमेगा बाई वी, इसको हम कहते हैं k. K stands for, guys, k is nothing but propagation constant. k को बोलता है propagation constant. k को हम कहते हैं propagation constant. लिख दो. Then replace this one here. Then this y equation will become, देखो, y is equal to a sin omega t minus omega by v means k x. Okay, call this equation number 3. And guys, this is very important equation among all which we are going to today derive. This is very important equation. Note down कर लो इसको. Note down कर लो. K means propagation constant. It's the ratio of omega by v. Omega means angular frequency. देखो इधर हम लिखते हैं omega means angular frequency divided by v stands for velocity of wave. Velocity of wave. This ratio we call k. Clear now? Hope it is clear. मुझे चिल्ला कर कुछ तो हो गया. Participants cannot see now your applications. Okay guys, hope it is clear to everyone. Next देखो क्या करते हैं मैंने इधर again. Actually yesterday we discussed another 2 equations. क्या था वो equation? V is equal to nu lambda. Correct? V value को nu lambda लिखे थे. Correct ना? Or else we'll do one thing. We'll write 2 more equations like this. देखो सुनो. Here omega by v is there. Omega by v. इसको मैंने कह दिया k. Means वी नो दैट ओमेगा का वैल्यू क्या होता है गाइस, 2 पाई बाई टी होता है, 2 पाई बाई टी ओमेगा होता है. इन डिनोमिनेटर v इज देयर, v इज इक्वल टू क्या होता है, लैम्डा बाई टी होता है, लैम्डा बाई टी. यस्टरडे हम लिख देते हैं ना, लैम्डा बाई टी इज नथिंग बट v इज इक्वल टू 1 बाई टी इज न्यू लैम्डा. In terms of that I written, substitute this value in terms of v, then it will become lambda over time t. t t से कैंसिल हो गया, k का वैल्यू कहाँ आ गया, 2 पाई बाई लैम्डा. लिख दो इसको भी, write on this equation, write on this equation. Note down guys, this is very important equations. Okay, if it is done means we'll move to the next page. Okay, देखो इधर और देखो, हमको एक इक्वेशन आया था y इक्वेशन, y इज इक्वल टू a sin ओमेगा t माइनस के एक्स, करेक्ट ना. k का वैल्यू कितना आ गया था, 2 पाई बाई लैम्डा. सब्स्टिट्यूट दिस वैल्यू हियर, आफ्टर सब्स्टिट्यूशन ऑफ दिस वैल्यू हियर क्या हो रहा है देखो, और एक इक्वेशन y इज इक्वल टू a sin ओमेगा t माइनस के प्लेस में 2 पाई बाई लैम्डा इंटू एक्स, ठीक है ना. एंड देन ओमेगा मीन्स 2 पाई बाई टी, सब्स्टिट्यूट दैट वन अगेन, y इज इक्वल टू a sin 2 पाई इंटू टी डिवाइडेड बाई टी माइनस 2 पाई x divided by lambda, correct. Now it in this term 2 pi, in this term 2 pi, take it as a common and outside ले लो, then this equation will become y is equal to a sin 2 pi t divided by capital T minus x divided by lambda. देखो और एक इक्वेशन मिल गया हमको, look into it. This is also a progressive wave, this is also a progressive wave. Here small t represents time at which we want to calculate the position of a particle, this small time. Capital time stands for total time period, means to complete one wave how long the time will be taken by that particle. And then x stands for is a distance where the particle we are finding. Lambda stands for wavelength, how much it is creating, how length between a crest and crest, or else trough to trough, right. Hope it is clear, hope it is clear, right guys. Okay, देखो, after this guys, after this we return one more equation, क्या था, v is equal to lambda divided by t, करेक्ट ना. इधर t है, t के लिए एक इक्वेशन बनो, t will be comes to this side means it will become t is equal to lambda by v, करेक्ट ना. now substitute this equation in this place, then क्या होता है देखो, y is equal to a sin 2 pi t divided by t के प्लेस में lambda divided by v means v will becomes to upside minus x by lambda. ये दोनों इक्वेशन में lambda कॉमन है, ले लो आउटसाइड, then y is equal to a sin 2 pi vt, here lambda taking outside minus x. guys देखो और एक इक्वेशन आ गया इधर, we got one more equation, this is also equation which represents the progressive, totally 4 equation मिल गया हमको, है ना. तो 4 equations, which are those four equations, will list out in a single point. देखो first equation क्या था, I will write in some other color, wait, फर्स्ट इक्वेशन था y इज इक्वल टू a sin ओमेगा t माइनस kx, करेक्ट ना? देखो इधर, करेक्ट, a sin ओमेगा t minus kx, right? That one, no? Yes, of course, it is an of three equations, na? Sorry, I told you four equations. Cool, cool, कोई बात नहीं. ओके, सेकेंड इक्वेशन कहाँ है? सेकेंड इक्वेशन देखो एक बार. सेकेंड इक्वेशन इज y इज इक्वल टू ये साइन 2 पाई v t बाई, सॉरी सॉरी नॉट दिस वन, 2 पाई ऊपर है ना? यस, इधर इधर है, दिस वन रेड कलर बॉक्स में है ना? दैट इज द सेकेंड इक्वेशन. क्या था? 2 पाई आउटसाइड, 3 बाई कैपिटल T माइनस x बाई लैम्डा. I closed everything. हाँ, yes it is done. Yes it is done. Sorry, I don't know, sometimes it will come. क्या करना है यार, थोड़ा adjust कर लो. Okay, if you are getting any disturbance means please drop a message like this. Okay, when you will drop a message, no, I got to know that yes, some students are live in a class, or else how I will feel? It's a one-way class. Right? Okay, then third equation क्या है? This one, y is equal to a sin 2 pi by lambda into vt minus x. This is the third equation. Okay, these are the equations which are very important for us. Clear? Tell me in the chat box whether it is clear or not. If it is clear means we'll do a problem. We'll do one problem, one or two. Then it will clearly gives the idea how to solve the problems. Yes, yes. Okay, cool. Yeah. Problem आ गया. Problem आ गया. Solve करना है. The wavelength of, this is off. The printing mistakes, थोड़ा adjust कर लो. The wavelength of sound emitted by the tuning fork is 2 meter in air. The speed is 345 meter per second in air and 1425 meter per second is in water. Find the wavelength of sound in water. Meanwhile guys, एक tuning fork है. आपको पता है ना tuning fork क्या होता है? ऐसे होता है, देखो. This is the tuning fork. आप शायद देखा है in this planet में. Planet में means in your JNV में, lab में. Okay. This is the story behind the planet of Earth only. Right? A tuning fork belongs to Earth only. Okay, this is a tuning fork. Actually, guys, it's a metal. Okay, this is a metal. What we will do? We're going to hold this point and we're going to hit one rubber pad here. Right? Rubber pad को hardly hit करते हैं. After hitting this one, if you're going to take that one to near your ear, okay, you will get some sound, because that time this tuning fork will be get vibrated. Due to this vibration, sound is coming. They're saying the same thing. Due to the vibration of this one, sound is generated. That generated sound का wavelength कितना है? 2 meter है. And then speed which is traveling is speed. V का value दे दिया है 345 meter per second. Right? Same sound when you're going to hard through the water. This is all about in air. Air. Okay. When you hard throw in water, water में क्या आता है? इसका speed होता है 1425 meter per second. This is a speed in water. This is a speed in air. And what will be the wavelength at the time in water? They are asking. सिंपल सा क्वेश्चन है. देखो एक बार लैम्डा के साथ साथ v का रिलेशन कैसा होता है. Check it and do the answer. I will give you exactly 2 minutes. Okay, and I'm expecting the answer from your end, guys. देख लो आंसर दे दो थोड़ा। Jane V. Mandya. Yes. How many of you there inside the classroom now? Ansari and Nagesh Vidyalaya Jamkhe. Good. Prasanna, your belongings to which school? Prasanna? Adneshwar Jamkhe. Great guys, great, great. How is summer in your region? Actually, I am present in Haveri. Okay, in Haveri में बहुत धूप है यार. Even we can't able to expect that one. बहुत हीट है, टेम्परेचर बहुत ज्यादा है. Jenny Mandya, yes, I got one answer. I can't able. Yeah, when I'm opening that one, no tab will be visible to all of you. Okay, try it, try it. I got one answer from Mandya. Great, great effort. But answer थोड़ा सा गलत है यार. थोड़ा सा गलत है आंसर. नहीं नहीं नहीं. No, 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 no. Listen, do listen. करंट चल गया. मेरा लैपटॉप कब तक वर्क होता है पता नहीं. Okay, we have an equation. No, V is equal to nu lambda. Yes, that is right answer. That is right answer. Finally, I got it. Nu is V is equal to nu lambda. Correct na? Either we required only relation between velocity and as well as the wavelength. Correct na? Okay, now देखो इधर velocity in air is exactly equal to lambda in air divided by denominator में क्या है? Again velocity in water is equal to lambda in water. है ना? This is the equation now. Simple है. Sir, frequency कहा गया? Actually, I will tell you guys, frequency will not change. Frequency will not change. One medium to another medium when energy will be moving. देखो, this is the first medium. This is the second medium. When energy will be flow from one medium to another medium, frequency will not change. It will be constant. Okay. If you want to know means after getting the values, try to find out the frequency. Then you will get an idea about it. Frequency value will be same आता है. Okay. Let's find out this one. Lambda चाहिए. Correct ना? Velocity of air कितना था? 345 divided by velocity of water कितना है? 1425 is equal to lambda in air 2 meter था, right? Divided by lambda in water we need to calculate. Cross multiply this one. आफ्टर क्रॉस मल्टीप्लीकेशन क्या होता है, लैम्डा इज इक्वल टू 1425 इंटू 2 डिवाइडेड बाय 345. Okay, just do calculate this one. Lambda value will get 8.26 meter. I got this answer from Mandya. Sorry, not Mandya. थोड़ा सा गलती किया था, कोई प्रॉब्लम नहीं, करेक्ट कर लो. This answer is given by Ballari team. Well done guys. Well done, well done. देखो इधर wavelength एयर में कितना था, 2 meter. When it is went to water, wavelength is increases. Meanwhile, we can say energy when it is moving from one medium to second medium. देखो वेलोसिटी इधर 345 था, वाटर में 1425 मीटर पर सेकेंड हो गया, वेलोसिटी चेंज हो गया, करेक्ट ना. लैम्डा इधर कितना था, 2 मीटर था, इधर सेकेंड मीडियम में लैम्डा 8.26 मीटर आ गया, राइट. वेलोसिटी हियर lambda value and velocity value will be changes, but frequency will not change, right. If you want means calculate, you will get a same answer for the frequency. That's it. Cool. This is the first question. We'll move to the next one. Hope you all understood this one. Correct now? If any doubt, please drop it out in the chat box. Here it is the second question. Question says here, guys, I will solve this first. Later on, I will give the what I will give. I will give you homework how to solve the question. Okay. सुनो, ध्यान से सुनो, थोड़ा भक्ति से सुनो. Okay. This is the question. Every year they will ask in a NEET. That's why. Clear है ना? देखो, a progressive wave is given by wave equation दे दिया है. Y is equal to 0.5 sin 2 pi t by 0.02 minus x divided by 0.5, where x and y are in meter and t is in second. Find the amplitude, frequency, wavelength, velocity of the wave. What we need to calculate first? Amplitude, frequency, wavelength, velocity. ये चारों क्वांटिटी को कैलकुलेट करना पड़ता है. Okay, we'll to calculate one by one. When we are going to calculate like this problem, first we need to compare this equation to the standard equation. क्या है standard equation? First you write this equation. Y is equal to 0.5 sin 2 pi t divided by 0.02 minus x divided by 0.5. We need to compare this one to standard equation. Standard equation क्या था? Y is equal to a sin omega t minus kx. This is the standard equation for us. Hey, great, great, great. Great guys. Amplitude तो बन गया, frequency, oh शाबाश, frequency तो हो गया. Next, 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 next. I'm waiting. I will wait for the 2 minutes. फ्रीक्वेंसी भी बन गया मंड्या टीम से. वेवलेंथ क्या होता है, वेलोसिटी क्या होता है देन? वेवलेंथ, ओ शाबाश. यूनिट भी होता है भाई, यूनिट भी लिखो, राइट डाउन द यूनिट बरेरी. ए बल्लारी टीम, ग्रेट. बल्लारी टीम आल्सो वेक अप. ನಾವೇನ್ ಕಡಿಮೆನಾ, right? Great, great. Next, last one, who will give? C ಅಂದ್ರೆ ಏನು? C means frequency na. Okay. Okay, done. Okay. velocity देखो आपका, I think you guys are getting that one right on the screen. What happened? Correct na? We'll go through one by one. Okay, first while comparing guys, देखो इधर. Those who are not yet get, please do listen. Amplitude को compare करना है, correct ना? When you compare these two, amplitude value कितना होता है 0.5. Without missing unit, you need to write out 5 meter, correct ना? That's great. And then here देखो omega t is there. Here t is there. Omega, when it will become, actually you need to compare that one by multiplying this one inside. Without multiplying, should not do that one. Okay, then this equation will become देखो 0.5 sin of, इधर अंदर से मल्टीप्लाई करने से 2 pi t divided by 0.02 minus, again multiply this one to this one here, 2 pi x divided by 0.5. क्लियर है ना? now देखो कंपेयर करने से ओमेगा टी वैल्यू की, हाउ इट इज equating to this quantity. देखो omega t value will be equal to 2 pi t divided by 0.02. इधर t से t मर गया, करेक्ट ना? देन ओमेगा वैल्यू कितना आ गया देखो 2 pi divided by 0.02. 0.02 कैसे दिखता है 10 to the power of -1 10 to the power of -2, करेक्ट ना? इधर देखो 2 pi divided by 2 into 10 to the power of -2. 2 से 2 कट गया, देन ओमेगा वैल्यू कितना आ गया देखो. ओमेगा इज देयर आस्किंग ओमेगा, नो राइट? फ्रीक्वेंसी रिक्वायर्ड. ओके, कोई प्रॉब्लम नहीं, आई विल सॉल्व एवरीथिंग. ओके, देन देखो इधर 10 to the power of -2 अपर, इफ इट इज कम्स टू न्यूमरेटर मींस 100 pi हमको ओमेगा मिल गया, करेक्ट ना? In a similar way, we will calculate the k value also. It will give the idea. Okay, no problem. Sorry, it's by mistake. Okay, we need to calculate your frequency, wavelength, velocity. We'll calculate. No worries. One by one. Cool. इधर next क्या है? kx है. kx का वैल्यू कितना को इक्वल हो रहा है देखो इधर. kx वैल्यू will be equal to 2 pi x divided by 0.5. करेक्ट है ना भाई? x से x कैंसिल हो गया. k वैल्यू विल बी इक्वल टू, नाउ क्या हो रहा है इधर 2 pi, अगेन 0.5 को 1/2 लिख सकते हैं. इट विल कम्स टू न्यूमरेटर मींस डायरेक्टली वी कैन राइट 4 pi. k वैल्यू मिल गया हमको, करेक्ट ना? k वैल्यू के लिए एसआई यूनिट क्या है देखो इधर. k इज इक्वल टू, आई टोल्ड यू 2 pi by lambda also. 2 pi is a constant quantity. k is equal to 1 by lambda. 1 by lambda, lambda is in meter. 1 by meter, meter is nothing but k is equal to meter inverse is the SI unit. Okay, don't forget, this is the meter inverse, करेक्ट ना? ये प्लेस है हमको, बहुत प्लेस है, करेक्ट? Okay, after calculating these two terms guys, let us calculate one by one. एम्पलीट्यूड हो गया. फ्रीक्वेंसी कैलकुलेट करना है, मीन्स क्या करना है हमको? फ्रीक्वेंसी के लिए एक यूनिट है, क्या है फॉर्मूला है ना, फ्रीक्वेंसी. ओके, विल डू वेवलेंथ भी है. ओके, देखो इधर एक्चुअली गाइस k इज इक्वल टू 2 pi by lambda है. विल कैलकुलेट ऑन बाय, नो प्रॉब्लम. 2 pi by lambda. lambda if you want to calculate means lambda is equal to 2 pi by k लिख सकते हैं, करेक्ट ना? इधर 2 pi by k वैल्यू तो 4 pi है, राइट? pi pi कैंसल, 2 1 जा 2 2 जा, मींस 1/2 आ रहा है. मीनवाइल lambda वैल्यू इज इक्वल टू 0.5 मीटर, राइट? lambda इज इक्वल टू 0.5 मीटर. क्लियर ना? आपको कितना आ गया था देखो. दिस इज माय कैलकुलेशन, इज इट करेक्ट, राइट? yes 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 guys, you did it, करेक्ट ना? lambda हो गया, वेवलेंथ हो गया, then we need to calculate frequency and as well as velocity. देखो वेलोसिटी के लिए इक्वेशन है एक, क्या है वेलोसिटी के लिए इक्वेशन, v इज इक्वल टू ओमेगा बाई के, ओमेगा अपॉन के, करेक्ट ना। कहाँ से आ गया यार ये, हम लिख देते k इज इक्वल टू ओमेगा बाई वी, करेक्ट। सुनो ओमेगा बाई वी था ना, ओमेगा का वैल्यू क्या है, v का वैल्यू क्या है, देखो ओमेगा का वैल्यू 100 पाई है, करेक्ट ना। एंड देन k का वैल्यू कितना आ गया, k वैल्यू 4 पाई है, 100 पाई डिवाइडेड बाई 4 पाई, लिख दो इसको इधर, देखो इधर ओमेगा वैल्यू 100 पाई डिवाइडेड बाई v का वैल्यू 4 पाई, पाई से पाई कैंसल, 4 1 जा 425 जा, k वैल्यू मिल गया हमको, k वैल्यू व्हाई इट इज नीडेड, v राइट, सॉरी सॉरी इधर लिखना था, इट इज मिस्टेक, हियर 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 हमको लिखना है, 2 times I written, no pardon guys, okay 100 पाई डिवाइडेड बाई k का वैल्यू 4 पाई, पाई से पाई कैंसल, वेलोसिटी कितना मिला, v इज इक्वल टू 25 मीटर पर सेकेंड, इज इट राइट। किसको आ गया था ये वेलोसिटी, देखेंगे, राइट JNV, विच वन दिस इज, मंड्या, राइट, वेलोसिटी उसको करेक्ट आ गया। नेक्स्ट थिंग, नेक्स्ट देखो वेलोसिटी हो गया, फ्रीक्वेंसी बाकी है। फ्रीक्वेंसी मीन्स गाइस वी नो वन इक्वेशन, क्या है, v इज इक्वल टू न्यू लैम्डा, करेक्ट ना। हियर है फ्रीक्वेंसी, वेलोसिटी है, लैम्डा भी है, फ्रीक्वेंसी इज इक्वल टू v बाई लैम्डा होता है, राइट। v का वैल्यू कितना है 25, लैम्डा का वैल्यू कितना था 0.5 मीटर, करेक्ट ना, 0.5, हियर 25 डिवाइडेड 0.5 को हम लिख सकते हैं 1/2, if it is comes to numerator frequency will be 50 hertz, right, all the answer you people are given exactly right, amazing guys, awesome, okay, excellent. I will give you one more problem, try to solve this one in home, okay, try to solve this one in home. problem क्या है ना, this is for homework, प्रॉब्लम का नाम है इधर y इज इक्वल टू 0.05 साइन पाई बाई 2 10t माइनस 40x माइनस पाई बाई 4, दिस इज द होमवर्क प्रॉब्लम, दिस इज योर होमवर्क प्रॉब्लम, note down this one. Okay, quickly we'll finish 2 more concepts. They are actually very easiest concepts. I will tell you what are those. Next one is intensity of wave, right? Yes, of course. Intensity of wave. Intensity of wave क्या है? देखो, सुनो. This is a source of light. Okay, source of light. Waves are coming. Actually, it is emerging the wave in all the direction. राइट मान लो आप इधर खड़े हुआ है, राइट, यू आर स्टैंडिंग वेरी नियर टू द सोर्स ऑफ लाइट, यू विल फील इट्स अ टू ब्राइट, करेक्ट ना, कंपेरेटिवली दिस प्लेस, राइट, बिकॉज इन दिस प्लेस एनर्जी, देखो इधर 3 waves are passing unit in this unit area, if you compare the same unit area here means the energy which will be flowing through this unit area will be less, correct now. Intensity means simple, energy which is flowing through in unit area, that is called the intensity. Intensity means energy flowing in a unit area, called the unit area in unit second, right? That is called the intensity of wave, right? इसको कैलकुलेट करना है ना. फर्स्ट विल डिस्कस दिस वन विद द एसआई यूनिट. ओके, एसआई यूनिट क्या होता है इंटेंसिटी के लिए? देख लो, एसआई यूनिट के लिए आई टोल्ड यू दैट एनर्जी कैरी होना चाहिए किधर? पर यूनिट एरिया इन अ यूनिट सेकेंड. एनर्जी के लिए एसआई यूनिट होता है जूल डिवाइडेड बाय सेकेंड भी है एंड देन एरिया भी है. एरिया को मीटर स्क्वायर लिखते हैं ना. देन देखो इधर जूल पर सेकेंड है, वर्क डन पर सेकेंड पर टाइम, इट इज नथिंग बट वाट. करेक्ट ना? वाट पर मीटर स्क्वायर, it is an SI unit for intensity of wave, watt per meter square, right? And then they will ask the question like that, on which parameter the intensity is proportional. Actually guys, intensity is proportional to the frequency square of the frequency, and the intensity is proportional to the square of the amplitude, and then intensity is proportional to the medium density of that medium के ऊपर intensity proportional होता है, and then intensity is proportional to the velocity of the wave. इन चारों चीजों के ऊपर इंटेंसिटी डिपेंड होता है. इस चारों चीजों को क्या करना है, एक ही इक्वेशन में लिखना है. I is proportional to f square a square rho v. Clear है ना? And then here we need to replace this proportionality constant and we need to bring one constant value here. That constant value will be here 2 pi. That's it, 2 pi. Remaining thing will be f square a square rho v. This is the intensity equation. This is intensity equation. Clear? Hope it is clear. I hope it is clear. We'll move to the next one. Superposition of wave. Guys, this is very important. Actually, देखो, this is one wave. देखो, ध्यान से देखो. This is the first wave which is moving in the medium. Amplitude थोड़ा कम हो गया, adjust कर लो. Okay, same amplitude होना चाहिए. Condition तो पता है ना? Now another particles also moving with the same pace. Now that wave has a little greater amplitude than the first one. करेक्ट ना? थोड़ा सा एम्पलीट्यूड ज्यादा है. मीन्स मान लो y1 पहले का था, सेकेंड वन का क्या हो गया y2. ये दोनों को सेम ही वेव ने रिप्रेजेंट करना है. इधर थोड़ा मुश्किल हो गया, इसलिए मैंने दो वेव से ऊपर मेंशन किया हूँ. ओके, हियर सुपरपोजिशन मीन्स एक के ऊपर और एक वेव आ गया तो क्या होता है, राइट? Definitely. I will tell you. Okay, now first we will complete this one. It's a short one. Okay. Now, when it happens, now we need to add these two waves by using vector addition. Vector addition से add करना है. किसको? ये दोनों wave को. Here, vector addition means resultant wave equation y is equal to y1 plus y2 होता है. Clear ना? This is what is superposition of wave. In this superposition of wave, superposition is nothing but guys, एक के wave के ऊपर और एक wave क्या होता है, overlap होता है, right? This is known as the superposition of wave. That's it. Clear ना? ये superposition of wave में again two kinds. One is constructive interference, another one is destructive interference or destructive superposition of wave. कैसे होता है देखो इधर, सुनो. दिस इज द फर्स्ट वेव. ओके, इसका एम्पलीट्यूड है a1 or else just you call ये wave का name था y1, right? Another one wave which is moving in this direction, same direction with the same pace. Same pace means first wave will be started from 0 means second wave also started from 0. So first wave will be ended at 5 means second wave also ended at 5. Those wave we called same pace. This is I'm going to call y2. इसका amplitude कितना होता है ये 2. Now देखो ये दोनों वेव क्या हो गया सुपर इम्पोज हो गया. द रिजल्टेंट वेव कहा होता है ना when it is superimposed with the same pace the resultant wave will be like this. बहुत ज्यादा एम्पलीट्यूड से होता है. Now what we need to do, we need to add these two waves. Y is equal to y1 plus y2 होता है along with the vector addition. Along with the vector addition. Here a1 plus a2 हो गया, इसलिए क्या हो गया रिजल्टेंट वेव का एम्पलीट्यूड बहुत ही ज्यादा हो गया. करेक्ट ना. इफ what if देखो और एक इक्वेशन है. दिस इज आल्सो अ वेव, दिस इज आल्सो वेव. इसका एम्पलीट्यूड क्या है a1 है, a1 है. now I will take one more wave which is actually starting from this end like this, or else okay I will take in a same phase only. I will take same phase, I will explain it. सुनो सेकेंड वन सेम फेज लेने से आता है क्या नहीं आता है. ओके आउट ऑफ फेज विल टेक, it will start in a reverse order direction, it will be moving like this. Okay, this is y1, this is y2. now if you go, this is the amplitude a2. वेक्टर एडिशन करना है मैंने बोल दिया. y1 को y प्लस y2 करना है करेक्ट ना रिजल्टेंट वेव के लिए. बट y1 is acting upward direction, y2 is acting downward direction. That's why while writing y2 we need to put a sign negative one opposite to the first wave. Then y value will become y1 minus y2. y1 minus y2 means is it is constructing or adding? No, it is actually कम हो रहा है एम्पलीट्यूड. मींस एट द टाइम ये दोनों वेव मिलकर एक और एक वेव को क्रिएट करता है. दैट वेव एम्पलीट्यूड विल बी लाइक दिस somewhat. This is the resultant wave. Clear na? This is destructive wave. Destructive wave means wave का amplitude decrease होना, constructive means wave का amplitude increase होना. ये दोनों कॉन्सेप्ट है सुपरपोजिशन प्रिंसिपल के ऊपर. क्लियर आपको? दिस इज ऑल अबाउट टुडेस क्लास गाइस. एक्चुअली बल्लारी टीम यू आर आस्किंग इंटेंसिटी. नो आई विल एक्सप्लेन यू विद इन अ मिनट. ट्राई टू लिसन. देखो क्या हो रहा विद इन अ मिनट. आई वुड लाइक टू कंप्लीट दिस वन सुन. दिस इज सोर्स ऑफ लाइट. ये क्या है सोर्स ऑफ लाइट. ये सोर्स ऑफ लाइट क्या कर रहा है लाइट को एमर्जेंट कर रहा है इन ऑल द डायरेक्शन. when you stand nearby the very near to the source of light you will be feel very brightest light because so many in a unit area. If you compare unit area, the wavelengths which are coming through this unit area which is very high number of waves will become. Okay, same if you're going to stand for a long distance क्या होता है same unit area if you're going to consider here means here the waves which are passing through this unit area comparatively come or less for the first position. Here you might be see, you might be feel something correct ना. brightness कम हो गया, brightness ज्यादा हो गया, right? It is actually based on the wave or energy which is passing through in a unit area in unit second, right? That is called the intensity of wave. How much energy or else how many waves which are passing through in unit area. This is one of the unit area in unit time or in 1 second. That is the measurement of one separate physical quantity. We call intensity of wave. Clear enough guys? Hope everything is explained apart from Doppler effect. Okay, I will try to explain that one Monday, or else Monday onwards I will start thermodynamics, heat transfer and thermodynamics. Until then take care guys. Okay, bye bye. Okay, something what? Yes. Thank you, guys. If you have any doubt, means please do call. Means do call from Sanjay. Okay, I will give the answer. No worries. Okay, fine.